This video is going to cover the solution for number 5 on the Simplifying Rational Expressions quiz from Algebra 2. Once again, we are finally into some truly challenging stuff here. There's quite a bit of factoring to be done, so we're going to get right into it. But if you missed any points at all on this problem, you should be following the entire solution. So we've got two binomial patterns here. We'll start with x squared minus 9. X squared minus 9 is a difference of two perfect squares. So we have to follow our pattern for that, which is on our factoring flowchart, which again you're allowed to use. It says it right there in the directions. So our factoring flowchart says that if we have a difference of two perfect squares, a squared minus b squared, that would factor into a plus b and a minus b. So x is obviously your a. B would be 3 because the square root of 9 is 3. So this would factor into an x plus 3 and an x minus 3. So those are the first two things in our numerator, x plus 3 and x minus 3. Then we have x cubed plus 64. That is a sum of two perfect cubes. So x cubed plus 64. 64 is 4 cubed. So we should be following our pattern, again on the factoring flowchart, for the sum of two perfect cubes, which says that we would factor that into a plus b times a squared minus ab plus b squared. So if you look, a is x and b is 4. So that would factor into x plus 4 times x squared minus 4x plus 16. That trinomial will never factor again. So our other two factors in our numerator are x plus 4 and x squared minus 4x plus 16. In the denominator, we have a pair of simple trinomial factoring problems. So x squared minus x minus 20, which means we're looking for a pair of numbers that multiplies to negative 20 and adds to negative 1. That'd be negative 5 and positive 4. So that will factor into an x minus 5 and an x plus 4. So those are our first two factors in our denominator. And then we have our other trinomial, which is x squared minus x minus 12. So there we're looking for a pair of numbers that multiplies to negative 12 and adds to negative 1. That would be negative 4 and positive 3. So that would factor into x minus 4 and x plus 3. So we fully factored. We're done with step 1. Now we move to our excluded values, and this time we have 4 excluded values. So our excluded values, and there's more of them, so we're going to have to sort of conserve our space here, would come from setting each of those equal to 0 and solving for x. So x minus 5 would give us an excluded value of 5. X plus 4 would give us an excluded value of negative 4. X minus 4 would give us an excluded value of positive 4. And x plus 3 would give us an excluded value of negative 3. So again, somewhere you have to have those 4 values listed as being excluded values. Then we would go in and we would cancel any common factors between the numerator and the denominator. So I see an x plus 3 that would cancel and an x plus 4 that would cancel, which means our final solution would be what is left. On top we have an x minus 3 and the trinomial x squared minus 4x plus 16. On the bottom we have an x minus 5 and an x minus 4. So our solution would be that fraction. One problem to go. If you missed number 6, then you will need to watch the final video.